Okay, so let's start with the section 1, celestial equator and ecliptic. So let's start by understanding two concepts in astronomy, the celestial equator and the ecliptic. So celestial equator, let's imagine the Earth equator, it is the invisible line that divides the planet into the north and the south hemisphere. And this image the project that line into the expanse of space, and this imaginary projection forms the celestial equator, which is a fundamental reference in celestial navigation. So if you stand at the equator on Earth, the celestial equator would appear as a straight line passing overhead from east to west of your head. However, as you move toward the poles, the celestial equator will shift toward the horizon. For example, if you are at 40 north latitude, the celestial equator would appear 90 minus 40, which is 50 degrees above the southern horizon. So we have done in celestial equator. Let's talk with ecliptic. The ecliptic, on the other hand, show the apparent path that the sun takes across the sky over 1 year. It's not aligned with the celestial equator because Earth axis is of 23.5 degree relative to its orbit around the sun. So this is why we have experienced seasons in our Earth. And throughout 1 year, as Earth revolve around the sun will appear to move along the ecliptic. For example, in June, the sun is at its the most north point relative to the celestial equator, near the constellation Gemini. In the other hand, in December, the sun will be in its southmost point near the constellation Sagittarius. So, because the ecliptic and celestial equator is not the same line, so they have two intersecting points. The first one is vernal equinox in March, and the second one autumnal equinox in September. So these intersections are essential to define time and notice the change of seasons in our Earth. And understanding these two concepts of these two lines will make us understand how celestial objects move in the sky, like planet, moon, or even the sun, all follow paths close to the ecliptic. And these line, ecliptic and equator, can answer these types of questions. So this is the section 1. Okay, so let's move to section 2, equinox and solstice. So what is equinox? So twice a year, the sun will cross the celestial equator. These moments are known as the vernal equinox, which occur around March 21st, and the autumnal equinox, which occur around September 23rd. So these are as I mentioned, the intersections between the celestial equator um the ecliptic. These the two lines. So during this time, the sun is directly above the equator. This alignment causes day and night to be approximately equal everywhere on Earth. And on the vernal equinox, the sun will move northwards, making the start of spring in the northern hemisphere. On the autumnal equinox, the sun will move southward, making the start of fall. And if you observe the sky on equinox, the sun will rise in the east and set exactly in the west, regardless of your location. So let's move to solstice. Solstice occur when the sun reaches its maximum or minimum angular distance from the celestial equator. So let's talk with summer solstice, which occur around June 21st. The sun is at its highest point in the sky for the northern hemisphere, and this makes the longest day of the year, with the sun rising in the northeast and setting in the northwest. The sun is directly overhead at the Tropic of Cancer or 23.5 north latitude. Um, and the second one, apart from summer solstice, is winter solstice, which occurred around December 21st. The sun is at its lowest point in the sky for the northern hemisphere. This makes the shortest day of the year, with the sun rising, on the other hand, in southeast and setting in the southwest. The sun is directly overhead at the Tropic of Capricorn, or 23.5 south latitude. So let's talk about differences in daytime and nighttime. During the summer solstice, the northern hemisphere experiences the longest daytime and shortest nighttime because the sun takes a higher, longer arc across the sky. On the other hand, during the winter solstice, the opposite happens. Days are shorter and nights are longer because the sun is lower and shorter. So let's move to the sun part. So imagine tracing the sun's path in the sky on June 21st and December 21st. In summer, the arc will be much higher and last longer. In winter, the arc will be closer to the horizon. During the equinox, the sun's paths align with the celestial equator, resulting in equal day and night. So here is summary of this topic of the section 2.
Next, let's talk about the equatorial coordinate system in the problem 3. First, what are the reference point and plane of the system? First, reference point, we use the vernal equinox as a reference point, and for the reference plane we use the celestial equator itself. Yes, and next I will talk about the meaning of declination and right ascension. So both of these I compare it to latitude and longitude in the version of celestial. First, declination. It's similar to latitude on Earth, so it measures how far a celestial object is from the celestial equator. So it can be measured in degree. For the positive values, it means that the object is north of celestial equator, but for the negative value, in the opposite side, it means that the object is south of celestial equator. Yes. And next, the second one, right ascension. It's like longitude, but is measured differently. So it tracks how far a celestial object is it is of the vernal equinox. So it different from declination because it's measured in hours, minutes, and seconds, because the sky rotates 360 degrees in 24 hours, right? So therefore 1 hour of right ascension is equal to 15 degrees of sky rotation. Okay, next, for the problem 4, I will talk about how to identify the declination from an observer in horizontal coordinate system. Yes, I will give you 2 examples. But first, let's talk about how to find the declination. The first step, you need to know the latitude or your location. The location. So the second step, you can find the NCP or SCP, and you can find the CE. And lastly, you can know the declination. Okay, for the first example, given the latitude is maybe latitude 40 องศาเหนือ Yes, so the NCP is around this, right? NCP is around this 40 degree. Yes, and you will know immediately that CE is this because CE is perpendicular to NCP. Yes, given the star is about around this, you can So the declination is this theta, right? Therefore, the this degree is 90 minus 2 theta. And after this, you just find what is this degree by the method that teacher King have taught you in the class. Yes. For example, if the theta is 15, so no, sorry, if 90 minus theta is 15, so you can know that theta is, so this is the declination. Let's move to another example, the second example. Given if the latitude is maybe 30 degrees south, so you can change the NCP to SCP. So SCP is right there. Boop. This is the SCP 30, yes. Sorry. And you can know immediately also this is CE, yes, given the star right this. Boop, 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 boop. This is theta, this is 90 minus theta. So as the first example, if you can measure this, you will know this theta. So it is the declination. Okay, for the last problem, I will tell about what are the circumpolar stars and how to identify the circumpolar stars. Okay, first let's talk about what are the circumpolar stars. So these are the stars that never rise or set, but instead trace circles around the celestial poles. So how to identify these stars? I will tell you easily. So for the circumpolar gain, so the declination need to much more than or equal to 90 degree minus 2 observer's latitude. For example, like earlier example, if the latitude is 40 north degree, I will, this is the NCP, right? This is CE, NCP, CE, star right there. Boop, 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 boop. This theta. So I will call this is a threshold to identify the circumpolar star. For this example, the threshold is equal to 90 minus 40, which is the 50 degree, right? If the declination, which is this theta, okay, given theta is maybe 60 degrees, so it more than 50 degree, therefore it is the circumpolar stars. However, if this theta is like 30 degree, so it less than 50 degree. It is not circumpolar. Yeah, easy, right? Yeah, that's all.